on October 19, 2017. An ordinary night for astronomers became the night the universe gave us a visitor. Robert Varick was at the Pan-STARRS Observatory in Hawaii, scanning the sky the way astronomers have done for centuries, when a strange dot of light appeared in his telescope data. At first glance, it looked like another asteroid, the kind that drifts around our solar system in predictable orbits. But the numbers told a different story. This object wasn't moving like anything local. It was racing through space at nearly 59,000 miles per hour, fast enough to cross the entire United States in less than 3 minutes. Even more startling, its trajectory didn't bend in the way every planet, asteroid, or comet is forced to bend by the sun's pull. Instead, its path cut through the solar system like a tourist who had no plans of staying. It was coming from far beyond, from the darkness between the stars. For the first time in history, we had direct evidence of an object that was born outside our solar system, passing through ours on its way back into interstellar space. A cosmic messenger we didn't expect, moving too fast for us to catch and too strange for us to easily explain. Scientists scrambled to point every telescope they could toward it. They had only days, maybe weeks, before it would fade into the distance forever. And in those frantic hours of observation, they realized this was no ordinary rock drifting through space. What they found only deepened the mystery. At first, many assumed the strange object was just another comet. After all, comets are the icy wanderers of the solar system, often tumbling in from the edges to make a brief, fiery visit before retreating again. But almost immediately, that explanation began to fall apart. As astronomers measured the light reflecting off its surface, they tried to reconstruct its size and shape. The first estimates painted a bizarre picture. A body stretching perhaps 1,300 feet long, but only about 1/10 as wide. A shape so elongated, it resembled a cosmic cigar drifting silently through space. No other natural object had ever been seen, with proportions quite like it. Later refinements suggested something even stranger. A flattened form, more like a pancake, nearly 400 feet across, but barely 60 feet thick. And while shape alone would have been enough to puzzle scientists, there was another problem. Comets, when they approach the sun, shed material. Their surface is warm, ice vaporizes, dust streams out, and we see a glowing tail arcing behind them. It is the signature of a comet's very identity. Yet this traveler showed none of that. No mist, no cloud of debris, no tail stretching across the sky. It moved silently, cleanly, betraying no hint of evaporation. So what was it? Too odd to be an asteroid? Too quiet to be a comet? Just a dark, elongated body, twisting gently as it flew, reflecting the faintest trace of sunlight back toward our telescopes. A shape no one had expected, behaving in ways that challenged everything we thought we knew about visitors from the deep. And as it slipped further into the solar system, its strangeness was about to multiply. When the object made its closest approach to the sun, just 23 million miles away, closer than Mercury's orbit, astronomers expected it to slow and swing around, just as gravity demands. That's what every rock, every comet, every asteroid has ever done when falling past the sun's immense pull. But this time, something else happened. Instead of simply coasting along, the object began to accelerate. Its speed jumped to more than 190,000 miles per hour, nearly 55 miles every single second. Faster than any spacecraft humanity has ever launched. Faster even than Voyager 1, the most distant probe we've sent out. The troubling part wasn't just the speed itself, but the cause. Normally, when comets gain a little extra push, it comes from jets of gas venting off their icy surfaces as they heat up. Like miniature rocket engines, these plumes shove the comet forward. But astronomers saw no such jets here. No vapor trails, no halo, no outward signs of activity. It was as if the object had fired invisible thrusters, slipping away with a force no one could account for. Numbers don't lie, and the numbers showed that this interstellar visitor was not behaving like any natural body we had ever tracked. Its acceleration defied our expectations, leaving only questions. Why was it speeding up? What force could push it across the solar system without leaving a trace? By now, it was clear that whatever this was, it wasn't just another rock drifting by, and the mystery only deepened as scientists rushed to give it a name that would come to symbolize both wonder and unease. They called it Oumuamua, a word from Hawaiian, chosen because the object was first detected in Hawaii and because the name carries a meaning as poetic as the mystery itself. A scout, a messenger from afar. It was the perfect title for something so fleeting, so alien to our skies. But by the time humanity had even realized it was there, the messenger was already leaving. Unlike planets or comets that circle back, this one had no return ticket. It had come in fast, and it was going out even faster, racing on a path that would never again cross the sun. Astronomers pointed every telescope they could, but the clock was against them. Each night, it grew fainter, slipping farther into the dark. Soon, it was beyond the reach of most instruments, shrinking into nothing more than a fading speck of light against the black canvas of space. Today, it is already billions of miles away, over 4.3 billion. Too far to study, too far to chase, and with every second, it carries its secrets further out, beyond our grasp. Oumuamua came, it revealed just enough to ignite debate, and then it vanished. A messenger that whispered something we couldn't quite understand, leaving us with only fragments of data and a lingering sense of wonder. In the months that followed, scientists tried to explain the impossible. And in 2021, two researchers, Avi Loeb of Harvard and his colleague Shmuel Bialy, offered a daring proposal. What if Oumuamua wasn't a natural rock at all? What if it was something built? Their idea was simple, yet astonishing. Oumuamua might be a light sail, an ultra-thin sheet, no thicker than a millimeter, pushed not by engines or jets, but by sunlight itself. Imagine a cosmic sailboat, catching the pressure of photons the way a ship's canvas catches the wind. At the right thickness, just a fraction of a millimeter, such a structure could accelerate smoothly without leaving any visible trace. This wasn't just science fiction. Humanity has already tested the principle. Japan's Icarus probe unfurled a sail in space back in 2010 and successfully used the push of sunlight to travel. If we could do it on a small scale, why couldn't someone else, perhaps long before us, build one large enough to cross the stars? Loeb and Bialy speculated that if Oumuamua were truly artificial, it might not be just a sheet of material. It could carry instruments, sensors, maybe even a transmitter, a probe designed to scan, to send information back to whoever launched it. And with such a design, the unimaginable travel times of interstellar space become less of an obstacle. A craft like this could drift across thousands of light years, silently coasting on the faintest breath of starlight. It was a bold idea, controversial, unsettling, and yet rooted in physics that worked on paper. To some, it was the first serious suggestion that Oumuamua might not just be a natural curiosity, but a messenger built by intelligence. But if Oumuamua really was some kind of craft, one thing seemed clear. It wasn't carrying anyone on board. The reason is simple and sobering. At the speed it was traveling, nearly 55 miles every second, even the nearest star, Proxima Centauri, would still be over 40,000 years away. To reach just a single light year would take more than 11 millennia. For living passengers, those timescales are unthinkable. So if it was artificial, it almost certainly wasn't a ship in the way we imagine ships. No crew quarters, no life support, no travelers peering out at the stars. More likely, it would be a probe, a silent, automated scout, perhaps guided by remote commands or programmed to act on its own. A machine that could survive the endless dark, shrug off the wear of cosmic rays, and keep moving long after any civilization that launched it might have changed, or even disappeared. The idea carries a strange weight. If it was built, it could have been drifting for tens of thousands, maybe millions of years before brushing past us. A message not meant for us, but for whoever might happen to notice. And in that sense, the name Oumuamua, the scout, the messenger, feels more fitting than ever. Of course, not everyone agreed with the idea of an alien probe. Many scientists argued there had to be a natural explanation, even if it was unlike anything we had seen before. And in time, several competing theories emerged. One proposal came from Alan Jackson and Steve Desch, who suggested Oumuamua could be a fragment of frozen nitrogen. Picture a chunk blasted from the surface of a distant world, something like Pluto, where plains of nitrogen ice stretch for miles. If such a fragment were knocked into space by a colossal impact, it could travel across interstellar distances. As it passed near our Sun, the nitrogen would slowly sublimate, turning from solid to gas, releasing invisible jets that could nudge it forward, explaining its sudden acceleration without leaving a visible trail. Another team, Darryl Seligman and Jennifer Bergner, offered a different idea. They argued that cosmic rays bombarding the body over millions of years might have broken down water molecules inside it, trapping hydrogen in the process. Then, as the sun warmed it, that hydrogen could have leaked out, producing tiny thrusts strong enough to speed the object up. Again, no dust, no debris, just invisible hydrogen escaping into the void. And some, like Karen Meach, proposed a simpler answer. Maybe it really was just a comet, but one unusually poor in dust, or shaped in a way we'd never observed before. After all, our solar system holds a staggering diversity of bodies, and nature has surprised us before. Each theory had strengths, each had gaps. None could be proven. But taken together, they painted a picture where Oumuamua didn't have to be artificial, only rare and profoundly strange. The mystery was so compelling that some scientists began asking an audacious question. Could we chase it? Could humanity actually send a probe after Oumuamua to uncover its secrets directly? Just 11 days after its discovery, a group of researchers proposed exactly that. They called it Project Lyra. The idea was to design a mission capable of catching up to this runaway visitor, even though it was already racing out of the solar system at nearly 200,000 miles per hour. The plans were ambitious. One option involved a series of gravity assists, slingshotting a spacecraft past Venus, Earth, and then Jupiter to build up the speed needed to follow the target. Another, even bolder idea was the so-called solar Oberth maneuver, diving a probe dangerously close to the Sun, then firing powerful engines at the moment of closest approach to gain an enormous burst of velocity. On paper, such techniques could push a spacecraft to more than 160,000 miles per hour, fast enough, in theory, to intercept the object decades later. But the engineering challenges would be immense. A probe would need heat shields capable of withstanding the sun's fury, like the carbon armor used on NASA's Parker Solar Probe. It would need a launch window timed with almost surgical precision, and even then, the odds of success would be slim. Launched in the early 2030s, the mission might not catch up to Oumuamua until the 2050s, and by then, the target could be tens of billions of miles away, a speck vanishing into interstellar night. The risks were obvious. It might miss entirely, or arrive too far away to gather meaningful data, or fail to slow down enough to study the object up close. But the rewards? Unprecedented. Even a failed chase would still give us humanity's first purpose-built interstellar probe, pushing the boundaries of exploration and teaching us about the space between the stars. Project Lyra asked the question no one had dared before. If the universe sends us a messenger, are we willing to follow? Oumuamua wasn't the only reminder that the outer reaches of our solar system are full of puzzles. In fact, the more we look into the Kuiper Belt and beyond, the stranger things become. Take Arakoth, for example. When NASA's New Horizons probe flew past it in 2019, scientists expected another featureless chunk of ice. Instead, they found a contact binary. Two worlds fused together like a snowman frozen in time. Its odd, flattened shape gave us new clues about how planets form, but also showed just how unusual these distant bodies can be. Then there was another Kuiper Belt object that spun so rapidly it should have ripped itself apart if it were made of ordinary ice and rock. Yet it held together, forcing astronomers to wonder if its composition was something entirely unexpected. Or consider 2002 UX-25, an object hundreds of miles wide that somehow has a density lower than water. By every model we know, something that large should have compacted into a denser body. And yet there it is, floating through the dark, defying the rules we thought we understood. Other discoveries are just as baffling. A world more than 1,000 kilometers across, showing signs of past water and strange heating deep within. Sedna, with its enormous 11,000-year orbit, raising the question of whether some unseen giant planet or something even stranger lurks in the far reaches of the solar system. Makemake, dazzlingly bright, but with a dark moon. ʻOumuamua, stretched into an elongated shape, spinning so fast it completes a day in less than 4 hours, and somehow surrounded by rings. Each of these oddities reminds us that our solar system is not a neat and orderly place, but a wilderness full of exceptions. And if even the worlds on our doorstep can break the rules, how much stranger might the visitors from interstellar space truly be? Oumuamua may have been the first of its kind we've seen, but it will not be the last. To make sure we're never caught unprepared again, scientists are already planning a different approach. Instead of scrambling to study the next interstellar visitor after it's already passing us by, why not have a probe waiting, ready to launch at a moment's notice? That's the idea behind the European Space Agency's Comet Interceptor. Scheduled for launch in 2029, it won't be aimed at a specific target right away. Instead, it will park itself at a stable point in space, nearly 1 million miles from Earth, and wait. When a promising comet, or perhaps another interstellar object, is discovered, the interceptor will spring into action. The mission will deploy not one spacecraft, but 3, a main probe and 2 smaller satellites. Working together, they'll swoop in from different angles, capturing the first close-up views of a pristine object that has never passed near the Sun before. By observing from multiple perspectives at once, they'll be able to piece together details about its shape, structure, and composition in a way we've never achieved before. It's a bold plan, born from the lesson of Oumuamua, because if another messenger comes hurtling through the solar system, we may only get one chance to learn from it. And this time, we'll be ready. You've just scratched the surface. Tap subscribe, and let's keep chasing the questions that make the world so strange and fascinating.